Hi. So today what we're looking at is factoring. And this is a topic we've looked at already, but just to kind of review this topic, we'll start by just kind of reviewing the general steps for factoring. So the first thing we want to look for is if there's a greatest common factor in the expression. So for example, if we consider problem number 1 here, if I consider the coefficients are 1, 7, and 18. Now those three numbers, 1, 7, and 18, are relatively prime. That means they have no common factor. So I can't take a greatest common factor from the coefficients. If I look at the variable parts, we have an x squared, an x, and then no x terms. So there's no variable greatest common factor either. So this has no greatest common factor in it. So we'll move on to our standard factoring. Now, all of our factoring problems begin by looking for finding two numbers that multiply to give us the leading coefficient, that's the a term, so in this case it's 1, times the constant term, that's the last term, negative 18, and have to add to give us the middle term, in this case negative 7. So in this case, where the leading coefficient is 1, this is relatively straightforward. If we simply find the two numbers that satisfy both of these two problems, the multiplication problem and the addition problem, we've essentially completed this problem. We can write our answer immediately in factored form. So the easiest way to do this, again, if you're not good at your multiplication table, and some of us might not be, is just to start with our number that we multiply to get. So we could multiply to get negative 18. So I'm going to start with that, and I'm going to look at all the things that divide into 18. Well, obviously, 1 works, so I could have negative 1 and positive 18, or positive 1 and negative 18. Both of these multiply to give me negative 18. 2 divides 18, so I can do negative 2 and 9, or 2 and negative 9. And already here I've seen that, hey, this is the one that adds to give me negative 7, but let's pretend we don't notice right away. The next one I would check is 3. Oops. So negative 18 divided by 3. So I'd have negative 3 and 6, 3 and negative 6. I'd then move on to 4. And because I don't get an integer value, I can skip this. I move on to 5. Again, I don't get an integer value, so I can skip this. An integer just being a whole number, right? And the next one I do is 6. That works, but I've already used 6. Right here, so I know I'm finished. So as soon as I work through my list of numbers and I get something that I've already got on my list, I know I'm done. So I found my two numbers that satisfy this, right? 2 and negative 9. And since these two satisfy these two, or these two numbers satisfy these two equations, and the leading coefficient is 1, I can go straight to a factored form, x plus 2, x minus 9. Really straightforward. Let's take a look at number 6, because something a little bit different happens here. So number 6, again, you got to remember, what's the first thing that we want to start by looking for? It's a greatest common factor. So if I look at the coefficients, 7 and 9, there's nothing in common between 7 and 9. Those are relatively prime. K squared and k, though, these have a greatest common factor. That common factor is k. So I can take that greatest common factor off. So I have k times. And then when we're factoring a greatest common factor off, what we're really doing is division. So what I'm doing is 7k squared divided by k. Well, that's just 7k. And 9k divided by k, well, that's 9. And it's easy to check that if I distributed this k back through, I'd be left with 7k squared plus 9. Now I just need to consider what I have left. Well, 7k plus 9 I know can't factor anymore because this is a linear term, right? The degree of my polynomial is 1. I have just an x to the first. It's like an mx plus b in here. And since there's already looked for greatest common factor, I know there can't be another one now, that this is finished factoring. Let's consider number 10. Okay, so again, the first thing I want to do is look for a greatest common factor. So if I look at the coefficients, I see right away that, hey, there's a greatest common factor in the coefficients. I can tell that right away because all of them are even, so they have to contain at least a 2. Let's see if they contain anything bigger than a 2, though. So I notice that 16 is just a power of 2, right? That's 2 to the 4th. So what I'm going to do is look to see if there's more than just a 2. Like, are there 2 2s in 24? Well, yeah, 24 is 4 times 7. Are there 2 2s in 80? Yeah, 80 is just 4 times 20. So I can take at least a 4 out. Now, the problem is, after I take that, if I take that, try to take more than a 4 out, the only thing left in 28 is 7, but there's no 7 in 16. So 4 is the biggest coefficient that I can take out. What I'll then do is look at the variable term. So I have an n to the 4th, n to the 3rd, and an n squared. Okay, so I can take an n squared out also. So what I'll take out is a 4n squared. And what I'm left with then is 7n squared plus 4n minus 20. And this now, the remaining part, is what I'm going to try to factor. So I'm going to look for two numbers that multiply to give me the 7 times negative 20. So that's negative 140. And then add to give me 4. Again, maybe this isn't obvious right away. Some of us it might be. But when in doubt, we're going to just start with 140. And the first things that I know multiply to give me a 140 are 1 and 140. Oops, but this is negative 140. So we have a negative 1 and 140 and a positive 1 and 140. And obviously neither one of these are going to work. So let's try 2. So we have negative 2 and 70, and then 2 and negative 70. Again, these don't work. Let's try doing 3. Divided by 3. Not an integer. Skip it. Divided by 4. Oh, so we have 4 and it's negative 4 and 35, and 4 and negative 35. Again, those don't work. They're not adding to give me 4. So let's try 5. That works. So I have negative 5 and 28. 5 and negative 28. And, oops, that's not what I wanted to press. This was. So we'll try 6. Doesn't work. We'll try 7. So I have negative 7 and 20, and positive 7 and negative 20. Okay, well, let's try 8. That's the next one. Doesn't work, not an integer. We'll try 9. Doesn't work, not an integer. And we'll try 10. So here we have 10 and negative 14 and negative 10 and positive 14. And this is the one that I want, right? This 14 times negative 10 does add to give me 4. Okay, so before, when we had done this, we were essentially finished at this point. For this kind, though, where the leading coefficient is not 1, here the leading coefficient is 7, we have a bit more work to do. So these two numbers, though, the 14 and negative 10, are really critically important to us. So what we're going to do is we're going to recopy our original problem, but instead of writing the middle term as 4n, I'm going to write it as 14n plus negative 10n. Because again, if I add those two numbers together, 14n and negative 10n, I still get positive 4. So I've rewritten this polynomial that was 3 terms, 7n squared, 4n, and negative 20, as a 4-term polynomial, 7n squared, 14n, minus 10n, minus 20. The factoring technique we would like to use when we do a 4-term, or when we deal with a 4-term polynomial, is typically going to be grouping. So what I'm going to do is I'm going to pretend that I have 2 groups here. So I'm going to consider this first group and look for a greatest common factor here. So I have 7n squared and 14n. Well, they have a greatest common factor. If I look at the coefficients, 7 and 14, well, those have a 7 in common. And n squared and n, those have an n in common. So I'm going to take out a 7n. So the 4n squared, that still stays out front. From this first group, I can take a 7n out. And again, when we're taking out a greatest common factor, what we're really doing is division. So 7n squared divided by 7n is n. 14n divided by 7n is 2. Then I'll look at the next group. So the next group, I'm going to look for a greatest common factor, negative 10n minus 20. So if I look at the coefficients, negative 10 and negative 20, well, those have a negative 10 in common. So I'm going to factor that out. And negative 10n divided by negative 10 is n. And negative 20 divided by negative 10 is 2. And now we're almost done. So what we're going to do is we're now going to look at this inside part as a whole. So 7n times n plus 2 minus 10 times n plus 2. If I look at these two pieces, the n plus 2 would be a greatest common factor, because I have 2 terms here, right? I have this guy is a term, and this guy is a term. So the n plus 2 is in common between both of them. So the next line, I still have this 4n squared out front, this greatest common factor they take out. I never touch it again, it just kind of stays out. I just have to remember to take it with me. I'll factor out my n plus 2. So when I factor the n plus 2 out, it's like dividing it. So this one will cancel, and this one cancels. So I'm left with 7n minus 10. So that is my factored form. And that reviews the main types of factoring of trinomials that we've worked with so far this semester. Thanks.